Let's prepare on soil structure and clay mineralogy. So firstly we will be seeing the structures of the soil. The first type is the single grain soil. So it will be mostly for a loosely packed soil. The grains will be also loosely packed. So we already know the void ratio for the loosely packed soil is nearly 0.91 and it is for densely packing it is 0.35. So this type of structure is normally present in the soil types like gravel and sand, which is of loosely packed thing. And the next type is the honeycomb structure. So honeycomb means it will be of a tightly and combinedly packed structure. So it will be mostly for the fine sand and silt type of soils. The next type is the flocculated structure. So this commonly occurs in clays. So here a net attractive force will be present there because the orientation of the soil will be like H2 phase. That is the particles edge and another particles phase will be combined together. So this will give a very strong bonding between the soil particles. So therefore the shear strength will be very high and compressibility will be low and permeability also will be high. So this is nothing but the conditions of the dry off optimum. So the soil having the moisture which is less than its optimum moisture content. So that will be providing these type of characteristics and it will be a flocculated structure. And the next one is the dispersed type structure. So this is an opposite to the flocculated. Here the face to face orientation of the particles of the soil will be present so that it will be not very tightly packed, and here a net repulsive force will be present there. It normally occurs in the remolded clay. So here the shear strength will be low and permeability will be low, but the compressibility will be high. So this happens when the moisture content is more than its optimum moisture content. So this is the wet off optimum condition. And the last one is the compost site type. So it is nothing but a combination of one or two types of structures. So what is remolding means when a cohesive soil like clay loses its shear strength. So that only we call it as the remolded clay. And what is thixotrophy means the regain of lost strength with time with no change in water content. So this also happens in the clay only. So when we add water to the clay and then making it to dry so that the strength of the clay will be regained again. So this process is called as thixotrophy. So this is very important in the case of pile driving. And the next we are going to see the mineralogy. So the minerals present in the soil particles. So first we will see in gravel and sand. So it is a loosely packed and large size soil particle. So here quartz, feldspar and mica will be present in a major component. And the next is clay. So in clay the minerals like kaolinite, illite, montmorillonite and halloysite is present. The halloysite is another similar to the kaolinite only. So these all minerals will be having a swelling characteristics in general because the swelling is only a main component in the clay. If we see the kaolinite means it will be having no swelling and no shrinkage at all. And if we see the illite means it is medium shrinkage and medium swelling, and montmorillonite means it is a high swelling and high shrinkage. So this will be normally present more in bentonite and black cotton. Bentonite is nothing but a volcanic ash. So this mineral is present means the water content of that soil also will be more. And the next is the diffuse double layer. So this is nothing but important property and a special property for the clay alone. So clay is generally a negatively charged particle, and always when it is reacted with water, a boundary of particles of water will be bounded to the outer layer of the clay. So this is nothing but the rigid layer and the loose layer. So first layer will be of rigid, which is closely packed, and then a loose layer will be packed. So this only we call it as the diffuse double layer. So the water held in this area we call it as the adsorbed water, and this property is a special one for clay, and this only imparts the plasticity characteristics to clay itself. We saw the diffuse double layer for clay when reacted with water, no, because water is a polar liquid, so that only it happens. But if you take a non-polar liquid, this plasticity cannot be given to the clay. So a kerosene is an example for this non-polar liquid. It cannot cause plasticity because it has the same ions of clay, so that a diffuse double layer cannot be provided by this type of liquids. And the next property that has to be known is specific surface area. So it is nothing but the total surface area per unit mass of the soil particle. It is very high for the montmorillonite, which is nearly 800 meters square per gram. Thank you and keep watching for the next lecture on the index properties of soil.